The Great Pyramid looks eternal, but its endurance is not mystical, it is material science. Modern petrographic analysis, microscopic examination of stone thin sections, has allowed scientists to study the pyramid's building materials at the crystal level. What they discovered is a story of deliberate selection and intelligent use of natural resources. The majority of the pyramid's core is built from Giza limestone, quarried directly from the plateau. Under magnification, this stone reveals fossilized marine organisms, tiny shells compressed over millions of years. These fossils are embedded in a calcite matrix that gives the stone high compressive strength. Compression is everything in a pyramid. Unlike beams or arches, pyramids distribute weight downward and outward. Every block presses into the one below it. The structure does not rely on tension, it relies on gravity, and gravity favors limestone. The stone's slight porosity also played a subtle role. Microscopic pores allowed minor stress redistribution and helped prevent catastrophic cracking under immense weight. For the outer casing, builders chose Tura limestone, a much finer grained and denser stone. Its low porosity made it resistant to wind erosion. When polished, it reflected sunlight brilliantly while resisting moisture penetration. Durability was not accidental, it was geological strategy. Then there is granite. Granite from Aswan is composed of interlocking quartz, feldspar, and mica crystals. Quartz gives hardness, feldspar gives rigidity. Together, they create a stone capable of supporting enormous loads without deformation. This is why granite was reserved for the king's chamber and the massive relieving chambers above it, areas where structural stress was greatest. And what of the mortar? For centuries, people assumed mortar held the pyramid together like modern cement. It did not. The mortar used at Giza, made from gypsum, limestone dust, and water, was not structural glue, it was a leveling compound. The blocks themselves bear the load. The mortar's purpose was precision, it filled microscopic gaps between stones, compensating for irregularities in the quarry-cut surfaces. This allowed massive blocks, some weighing several tons, to sit flush against each other with astonishing tightness. In many joints, a blade cannot pass between stones. The builders were not relying on adhesive strength, they were engineering contact surfaces so exact that gravity became the binding force. Modern analysis has also shown that the mortar sometimes contains trace minerals and impurities that improved its setting behavior in Egypt's dry climate. It hardened quickly, stabilized the placement, and then became secondary once the block settled under weight. The pyramid stands not because it is glued together, but because every stone was shaped, placed, and seated with scientific understanding long before the word science existed. The durability of the Great Pyramid is not magic. It is geology, physics, and craftsmanship, working in silent harmony.